Welcome everyone. Thanks for joining me today. In this video, we're going to work out this sample final exam for pre-calculus. We'll be working out every single question in this test. So feel free to work out the test on your own first, and then you can check your answers with mine. Let's dive into it. So let's go ahead and call this solutions file. For the first problem, we're going to be evaluating sine of 285 degrees. So we can say 285 degrees, if you were to draw that from standard position, that's the angle that goes around and terminates right here. So this is 285 degrees. And we know that from all students take calculus acronym that only cosine and secant are positive in the fourth quadrant. So sine will be negative. So we can say sine of 285 degree is equivalent to a negative sine of its reference angle. The reference angle is this angle right here. That is the reference angle. So we know the reference angle in the fourth quadrant is 360 minus 285 degree. That's going to give you 75 degrees. So we can say this is negative sine of 75 degrees. Now we can use the sum formula to find its exact value. We can use sine of 30 plus 45 because that's 75. So this would be negative. Let's pull out the negative and just put parentheses. So using the sum of two angles formula, we're evaluating sine 30 times cosine 45 plus cosine 30 and then sine 45. So now from memory, we know that sine 30 is 1/2, cosine 45 is square root of 2 over 2, cosine 30 is square root of 3 over 2, sine 45 is 1/2. And if you combine these, you'll have negative a square root of 2 over 4 plus square root of 3 over 2, 4. Sorry, you're multiplying the denominators. So that will be our final answer for this problem. You can write it this way, or you can multiply out the negative. So you'll have negative square root of 2 minus square root of 3 all over 4. Since they both have same denominators, we can join them into a single fraction. So that will be the answer to the first problem. Now take a look at the next problem. We want to find all solutions to this equation right here. Sorry for the overlap from the previous problem. So for number 2, we're going to find values for t that make sense to this equation. I'm going to go ahead and divide both sides by 2. So you'll have t squared is equal to 32. And then you can cancel out the square by square rooting both sides. So we have square root of t squared is equal to plus and minus square root of 32. So t is equal to plus and minus square root of 32. You might want to simplify this answer. Don't leave it right here. So square root of 32 can be simplified into 16 times 2 under the square root. And then 16 will come out as a 4. So you'll have t is equal to plus and minus 4 square root of 2. So two solutions, because it's a quadratic, you get two solutions for this particular problem. So for number 3, we want to find cosine 2 theta, given the tangent of theta is negative 4 over 3. We have to use the double angle formula for cosine. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. So we need to figure out sine and cosine, their values, and then plug it into the double angle formula from this information given. So tangent of negative 4 over 3, all that means is you can draw the right triangle on our xy plane. So from ASTC, we know that tangent is positive here and here. So that means my right triangle is either on the second quadrant or the fourth quadrant. And it doesn't matter which one you pick, either way, one of the values is going to be negative, sine or cosine. But then when you square them by plugging it into this formula, the negative will disappear. So I'm going to go ahead and draw the triangle on the second quadrant. So let's suppose theta is here. Tangent, by definition, is opposite over adjacent. So this is theta, across from it is the opposite length. This would be 4, this would be 3. Since this is parallel to the negative x-axis, that's where we put the -3, which means the hypotenuse, this is a Pythagorean's triple, 3, 4, 5, so this is 5. If you want, you can use the Pythagorean's formula, a squared plus b squared equals c squared, to find the hypotenuse. Well, now we can write down what cosine is. So cosine of theta, cosine is adjacent over hypotenuse. So that means cosine is -3/5. And sine theta is opposite over hypotenuse. So that's 4/5. And we're going to plug them right in here to get our values for the double angle. So cosine of 2 theta is equal to cosine squared theta, that's -3/5 squared, minus sine squared, that's 4/5 squared. And this is equal to -3/5 squared, that's 9/25. And 4/5 squared, that's 16/25. Now here we can do the subtraction. 9 minus 16, that will give us -7 over same denominator, 25. So that will be our value for cosine of 2 theta. For number 4, we're going to be solving this trigonometric equation. So let's go ahead and isolate the trig expression, which is secant theta. So I'm going to go ahead and add 4 to both sides. You have 2 secant squared theta is equal to 4. And then we can divide both sides by 2. You have secant squared theta is equal to 2. And then we're going to take the square root. So we have secant theta is equal to plus and minus square root of 2. So we're looking for a positive solution and negative solutions within this interval 0 to 2 pi. So if you go ahead and draw each solution, so we know from ASTC, that's the acronym, secant is the reciprocal for cosine. So if you know cosine of some angle, that gives you 1/√2, then secant is the reciprocal of that. So I know that for cosine, this is pi/4. So for secant, it will also be pi/4. Because secant, you can rewrite it as 1/cosine. So on the first quadrant, we get the positive solution. So this is right here. Now we know this has to be pi/4. So that's one solution. Then on the second quadrant, we get the negative solution. So only sign is positive. So that means we get the negative square root of 2. So that angle is going to be pi minus pi/4. So that would give you 3 pi/4. So our solutions are pi/4. That's on the first quadrant. Then 3 pi/4 on the second quadrant, which corresponds to negative square root of 2. And then here you get the next solution. So this will be the another negative solution. So this angle is going to be pi plus pi/4. That would be 5 pi/4. So another solution is 5 pi/4, where secant theta is negative square root of 2. And the last one will be on the fourth quadrant. So you get solution in every quadrant. So this one is right here, and this would be 2 pi minus pi/4, and that would be 7 pi/4. So our 4 solutions to this particular value, square root of 2 and negative square root of 2, are these set of angles. So as you can see, this one and this one gives you this positive square root of 2 for secant, and these two quadrant gives you the negative square root of 2. Moving on to the next problem, number 5. So for number 5, we're evaluating log base 2 of 1/64, call it x. Then in exponential form, this is 2 to the x equals 1/64. We can write 64 as 2 to the 6th power. So that can be written as 2 to the -6 on the right-hand side. On the left-hand side is just 2 to the x. Now, the only way this is true if the exponents are equal. So x has to be -6. So that would be the work for number 5. So here's the next problem. we're going to be solving this logarithmic equation. So I want to isolate the logarithmic term. So I'm going to move this to the other side. So we're going to add log base 9 of x plus 3 to both sides. So that gives us log base 9 of x minus 5 plus log base 9 of x plus 3 equals 1. Now here, using the laws of logarithms, since there is a sum between two logarithms, you can join them into a single logarithm. So you'll have log base 9 of x minus 5 times x plus 3 equals to 1. And here we can write this in exponential form. So I'm just going to make this smaller so I don't run out of space. All right, so this is 9 to the 1 power equals x minus 5 times x plus 3. And then we can expand the right-hand side. So you have 9 equals x squared plus 3x minus 5x, that's negative 2x minus 15. And then subtract 9 from both sides. So that gives us 0 equals x squared minus 2x minus 24. And so now let's go ahead and factor this. So we have 0 equals, this can be factored into x minus 6 and x plus 4. So we set each factor to 0, we get x equals 6 and x equals negative 4. Now let's check. So if I plug in x equals 6 into this expression, will the inside of the logarithm be positive? And it is positive, so this works. Now what about negative 4? When you plug in negative 4 into this and this, you get negative. So that's why this is not going to be an answer. So this we're going to reject. Our only solution to this problem is x equals 6. Sine inverse of negative 1/2 is actually negative pi over 6. So pretty much you ask yourself, sine of what angle gives us negative 1/2, where the theta has to be within its restriction, negative pi over 2 and pi over 2. So we know this theta has to be negative pi over 6, since you want the negative exact value of 1/2. So now we plug that in our original expression. So we're looking for tangent of negative pi over 6. Well, since tangent is an odd function, so I can simply pull out the negative sign and write tangent of pi over 6. And from memory, we know that tangent of pi over 6 is square root of 3 over 3. So this is negative square root of 3 over 3. That will be the exact value for this composition. For number 8, we're going to sketch this quadratic. So I'm going to rearrange the term. So f of x is equal to negative x squared minus 4x plus 1. Let's go ahead and find the intercepts. So you have the x-intercept is when the function is equal to 0. So we have f of x equals 0. That would give us negative x squared minus 4x plus 1 equals 0. Multiply both sides by negative 1. You get x squared plus 4x minus 1 equal to 0. Now you can try to use the quadratic formula here, since this is not factorable. So you get x equals negative b, negative 4, plus and minus a square root of b squared. So that's 4 squared. 16 minus 4, a is 1, c is negative 1, all over 2 times a. And this gives us negative 4 plus and minus square root of 16 plus 4. So that's 20 under the square root. And then all over 2. So this would give you negative 4 divided by 2. That's negative 2 plus and minus square root of 20. You can simplify that. So that's a square root of 4 times 5. And 4 will come out as a 2. So you have 2 root 5 for square root of 20. And then that 2 and this 2 from the bottom will cancel out. So you'll have simply square root of 5. So that's your x-intercept. So as a pair of coordinates, we can write this as negative 2 plus square root of 5 comma 0. And -2 minus square root of 5, comma 0. So these are the two x-intercepts. Now for the y-intercept, we're going to set x to 0. Now that's easy to compute. When x is 0, then these terms will drop out, so you just get 1. So the y-intercept is 0, 1. All right, now let's find the vertex. Since it's a parabola, it's going to have a vertex. X is equal to -b over 2a. So -b, so that's -4. A is -1, so that's -4 over 2 times a, -1. This will give you 4 over -2, which is -2. And the y-coordinate of the vertex would be f evaluated at -2. So plug this into the original, got 1 minus 4 times -2 minus -2 squared. And this will give you 1 plus 8 minus 4. So that would be 4 plus 1 equals 5. So that would be the y-coordinate of the vertex. So we got the intercepts, we got the vertex. Now we're ready to sketch this graph. Now also note that this parabola is facing downward. So that's another thing to keep in mind to make sure I have everything in the right place. So x-intercepts, they're not pretty. We're just going to estimate -2 plus square root of 5 and -2 minus square root of 5. So let's suppose the y-intercept and the vertex are right here. So here's -2 and 5. Let's say it's right here. And then, so the parabola would look something like this. All right, so I'm going to try to draw this the best that I can. Here's one half, here's the other half. So something like that. So something like this will be our parabola, not the best graph, but hopefully it's convincing to you. So let's call this the graph we're looking at. So here's the vertex. This is -2, 5. Here's one of the x-intercept. Here's the y-intercept. Here's another x-intercept. So that will be the sketch of this graph. So here's number 9. I'm going to go ahead and rewrite this angle right here so that I know how to sketch it, or you can convert it to degrees. So -13 pi over 4. Well, 4 divides 13, so I can write this as, so let's put the negative outside. Negative just means you're going clockwise. So you have 12 pi over 4 plus 1 pi over 4. That's 13 pi over 4. This is -12 over 4. That's 3 pi plus pi over 4. So we're going to draw this, but negative just means we're going to go clockwise. So let's go ahead and draw this in the unit circle. So here's our xy plane. We want to know the terminal point. So we want both x and the y coordinates. So let's suppose this is our unit circle. So 3 pi, so we're traveling this way. So that's what the negative sign means. So 3 pi just means you go around one time on this circle. That's 2 pi. And then you go around again. That's 3 pi, and pi over 4 just means a little bit more. So you end up right here. That's the point we're looking at. We want the x and the y coordinate. Now remember, see, since you're in the second quadrant, your x coordinate is negative. So where's the reference angle? Well, the reference angle is this piece right here. That's the angle we're looking for. And we know that's pi over 4. So this is pi over 4. So we're looking for, so our p, the terminal point, will be cosine of pi over 4 and sine of pi over 4. So we know cosine of pi over 4, that's negative root 2 over 2. So the point is negative root 2 over 2. Sine of pi over 4 is also root 2 over 2. So y is positive, so this is just positive root 2 over 2. So that would be the terminal point for this given angle. All right, so here's the next problem. We want to find the net change and the average rate of change for this particular function at these given values. So let's go ahead and find the net change. So the net change is simply the formula f of b minus f of a. So this is your a, the first x value, and this is your b, the second x value. So let's go ahead and find the first x value. So we're looking for f of a, which is f of 5. Plug 5 into the x in the function. You get 5 cubed minus 5 times 5 squared. And then we're going to evaluate this. I'm going to go ahead and make things simpler. I'll factor out 5 squared. Then I have 5 minus 5. So this gives me 0. And then f of b, it's going to be f at 10. So that's at the second x value. So we're looking for 10 cubed minus 5 times 10 squared. So again, I'm going to factor out 10 squared. So you'll have 10 minus 5. So that will give you 10 squared times 10 minus 5. Well, that will be just 5. So this is 110 squared. That's 100 times 5. That's 500. All right, so I found my f of a and f of b. Now let's go ahead and plug them in. So the net change is going to be 500 minus 0, which is 500. Now for the average rate of change, so the average rate of change, it's going to be the net change. So that's f of b minus f of a over b minus a. So we know the net change, that's 500. B minus a, well, that would be 10 minus 5. So that's 500 divided by 5, which will simply be 100. So the average rate of change is 100 and the net change is 500. So for number 11, we want to graph this by making a table of values. Now let me show you another way to do it other than making a table of values, but feel free to make table of values. Analyze this function. It's an absolute value. So we know that the absolute value, let's call it little f of x, of absolute value of x is going to be positive x whenever x is greater than 0, and we replace it with the negative x when x is less than 0 or equal to, let's put it that way. So I'm going to rewrite the big f of x. So our f of x is going to be, so for every x greater than or equal to 0, we can replace the absolute value of x with x. So you get x minus x for x greater than or equal to 0, and that would just be the constant function 0. Now let's plug in, well, not plug in, let's go ahead and separate it into another interval. So our big f of x is going to be, so now I'm going to replace absolute value of x with the negative x for x less than 0. So it's negative x minus x every time x is less than 0. So that's the function we're going to draw, negative 2x for big f of x. So it's kind of like a piecewise function. So you're going to draw f of x equals 0 on this interval, and you're going to draw negative 2x on this interval. Now, if you want to make table of values, feel free to do that. So here's a x column. Here is our y column. So let's pick some numbers. Let's say negative 2, 0, and 1. Just something simple and easy. And now here, I'm going to go ahead and plug these into my original function. When I plug in negative 2 into the original function, I get the absolute value of negative 2, that's 2, and then negative 2. So you have absolute value of negative 2 minus negative 2. This would give you 2 plus 2, which is 4. And then when you plug in 0, you have absolute value of 0 minus 0. That would be 0. And then when you plug in 1, you get absolute value of 1 minus 1. That would be 0. All right, so you see that when x is greater than or equal to 0, it's always going to be 0. When it's less than 0, it's just going to be the line with negative slope. So hopefully you start to see how this graph is going to look like. So when x is 0, we got 0. That's right here. When x is 1, we got 0. That's right here. And you can imagine when x is 2, you're going to get 0. When x is 3, and so forth. So if you connect them, you get this line right here. So that is your big f of x equals 0. And that's the interval when x is greater than 0. or equal to 0. Now, when x is less than 0, you have, when x is negative 2, we get 4. So suppose it's right here. And then when x is perhaps negative 1, it's going to be down here and so forth. So this will be the line for the other half. So that is the big f of x is equal to negative 2x. And you can see the line is decreasing. Of course, this is missing. So that will be the line for x is less than 0. So there you go. That's the graph of this function. So altogether, this entire piece together is the big f of x, which is absolute value of x minus x. For number 12, we want to find h inverse of negative 5 when h of x is equal to that. All right, so we know that for inverse functions, if this is the input for the inverse, then it must be the output for the original function. So we can set h of x equals to negative 5. So negative 5 is equal to 3 minus 2x. That's one way to do it. Another way to do it is to find the inverse formula and then plug in x equals negative 5. That will be like the quick way. Maybe not so quick, but that's another way to do it. But I'm going to do it this way. I think it's easier to just set the function equal to negative 5, since that will be the outcome for the original function. And then solve for x. Let's go ahead and subtract 3 from both sides. So you'll have negative 8 is equal to negative 2x. Divide both sides by negative 2. So you'll get x is equal to 4. Which means that h inverse of negative 5 is 4. So this will be one way to do it. Another way, just simply find the inverse formula, plug in negative 5. Let's go into number 13. So for number 13, we want to find these compositions and then substitute them and subtract. So let's find this first. So f of 2, well, that means I'm plugging in 2 into the f function. So f of x is right here, plug in 2. So you'll have f of 5 times 2 minus 3. So that's the first. Plugging in 2 into f. And then the outer f is waiting. So you have 5 times 2, that's 10 minus 3. That will be 7. Now that goes back into f. So you're composing f into f. So you're doing 5 times 7 minus 3. And then we figure out this number. So we get 5 times 7. That will give us 35. And then we subtract 3 from it. So that gives us 32. So f of 2 is 32. Now let's figure out the second portion of it, which is g of 3. So we plug in 3 into g, and then plug that into g again. So g of 3. So plug in 3 now into the g of x function. So you'll have 4 minus 3 squared, and that input goes back into g again. So you'll have g of 4 minus 9, and that would be g of negative 5. So negative 5 now goes back into g. So you do 4 minus negative 5 squared. So that would give us 4 minus 25. That is negative 21. So these are our outputs for those specific given compositions. Now for this entire composition that we're looking for, we want to find f of 2 minus g of 3. Well, we know f of 2 is this one right here. That's 32 minus g of 3. That's this one right here. So that's negative 21. Then we just combine them. This is 32 plus 21. So that's going to give us 53. So that will be our final result for f of 2 and g of 3. So for the next problem, number 14, we want to evaluate this. So let's rewrite it as a positive exponent first. So to write it as a positive exponent, I simply flip the fraction. So this is equivalent to writing 36 over 49 to the power of positive 3 over 2. And then I can distribute the power to each component since it's a division. So you'll have 36 to the power 3/2 and 49 to the power 3/2. And then you can write them as a radical. So this will be the square root of 36. And then we cube that. And square root of 49. And then we cube that. So the square root of 36, we know that's 6. And we cube it. And then square root of 49, that's 7. We cube that as well. So you have 6 cubed. Well, we know that's about 216. And then 7 times 7 times 7, that's going to give you about 343. So that will be the answer to this problem. Now let's go ahead and find number 15. So for number 15, we are going to find the difference quotient for this particular problem. Let's go ahead and figure out these pieces first. So f of 1 plus h, plug in 1 plus h into your function. Our function is 2 over x plus 5. So x is replaced with 1 plus h and plus 5. So this simplifies to 2 over 6 plus h. Then f of 1, so that's the second piece of our formula. That's going to be 2 over, replace 1 with, for x, you got 2 over 1 plus 5. And that would give us 2 over 6. You can simplify, but I'm going to keep it this way, so that way when I combine it into a single fraction, it'll be easier to work with. So let's go ahead and do that. So you have f of 1 plus h minus f of 1 all over h. F of 1 plus h is going to be substituted with this. F of 1 will be substituted with that. So you'll get 2 over 6 plus h minus 2 over 6 all over h. So now let's put the top into a common denominator. Multiply this by 6 plus h, 6 plus h, and this with 6 over 6. So the top now becomes 12 minus, and then here I can distribute that negative 2 out. So that would be negative 12 minus 2h all over the same denominator, 6 times 6 plus h divided by h. And then I can combine the top. So on top, these guys cancel out. So you are left with negative 2h over 6 times 6 plus h. And here I can write this as over 1 and reciprocate. So you'll have 1 over h. Now let's simplify this. So let's, let me get myself some space. So now I can simplify this further by canceling out the h and h here, and 6 and the 2. So we're going to do 2 simplifications. The h cancels, and the 2 and 6 will simplify. So we'll have negative 1 on top, and 6 and 2 gives you 3 on the bottom times 6 plus h. And that's pretty much it. That's your final answer, because nothing else will simplify. Now let's go ahead and take a look at 16. So we want to find the center and the radius of this equation that is in this expanded form. Let's rearrange the terms. So you have x squared plus, I'm going to put the next x term next to x squared. So it'll be minus 1/4 x. Leave a space since we're going to complete the square. Y squared plus 1/4 y, leave a space, equals 1 over 32. So now let's focus on the x term. I'm going to take half of this and square it. So if I take 1/4 half of it, I get 1 over 8, and then I square it. So that's going to be 1 over 64. And I add 1 over 64 to the other side. And we do the same thing with the y variable. Take half of that and square. 1/4, take half of it, you get 1/8. You square it, you get 1 over 64. Same thing, we add it to the other side to keep it balanced. And now let's write them into perfect squares. So this is x minus 1 over 8 squared. And these guys right here is 1 over, sorry, not that. It's going to be y plus 1 over b over 2. So that's 8 squared is equal to, now these we can just combine them. So we have 1 over 32 plus 2 over 64, which is 1 over 32. So I can just write this as 1 over 32. Add them up, so you'll have 2 over 32. And that simplifies to 1 over 16. So you have x minus 1 over 8 squared plus y plus 1 over 8 squared is equal to 1 over 64. So that is our equation in standard form of a circle. Now let's go ahead and write down the center and the radius. The center is going to have the x-coordinate 1, 8, the y-coordinate negative 1, 8, and the radius is going to be the square root of this number right here, 1 over 16, the positive square root. So that's 1 over 4. So those are the information we can write down by looking at the standard form of the circle. For 17, we want to find an equation of the line passing through the points this and that. So for an equation of a line, we need the slope. So slope is going to be denoted by m, and we know m is the change in y value, so we're changing x values. So we can say y2 minus y1 divided by x2 minus x1. Let's label our points, call this one x1, y1, x2, y2. Substitute them in here, so you'll have 8 minus negative 3 over negative 4 minus 5. So this would be 8 minus negative 3, that's 11 over 5, negative 4 minus 5, that's negative 9. So that's our slope. Now let's go ahead and write the equation of the line. We're going to use the point slope form. Y minus y1 equals m times x minus x1. So I'm going to use the first point since I already labeled that x1 and y1. Feel free to use the second point if you want, it doesn't really matter. So using that point, I sub in x1, y1, and our slope. You have y minus negative 3, that's y plus 3, equals negative 11 over 9, x minus 5. So that's the equation of the line. If you want, you can write this in mx plus b form, but this is good enough, so I'm going to stop it right here. So for number 18, we're going to be solving this inequality. Now, every time you're solving inequality, make sure one side is 0. So we're going to push the 5 to the left side. So we have x over x plus 2 minus 5 greater than 0. And now join the left side into a single fraction. I'm going to write this as over 1 and multiply by x plus 2, top and bottom. So that would give us the following. So let me just rewrite this. So you'll have x minus 5x plus 2 over x plus 2 greater than 0. And combine the top, you have x minus 5x, that's negative 4x, and then minus 10 all over x plus 2 greater than 0. And now you find the zeros. When will this expression be 0? So you set the top to 0. You find when the top is 0. So you have negative 4x minus 10 equals 0. You get 4x is equal, negative 4x is equal to 10. Divide both sides by negative 4. You'll get x is equal to negative 5 over 2. So that's one place when this is 0. And also on the bottom, it is 0 when x is equal to negative 2. So we take these zeros and we split up the real line into different intervals. So negative 5 over 2, well, that and negative 2 is right here, and then so forth. Now these are not included, so open circle at those. So we're testing this interval, negative infinity to negative 5 over 2, and then negative 5 over 2 to negative 1, sorry, negative 2, and then also negative 2 to infinity. Those are the interval we're testing. So now let's go ahead and pick a test values on each interval and test them. So in this interval, the first one, we can test negative 4. Then from negative 5 over 2 to negative 2, we can test negative 2.2, a little bit between negative 5 over 2. So negative 5 over 2 is about 2.5. So negative 2.2 is fine, or negative 2.3. Here we can test 0. That's easy. Now plug them into this expression. It's easier to work with. So you have negative 4 minus 10 over negative 4 plus 2. So the top is positive, the bottom is negative, so the ratio is negative. Now we do the same thing for negative 2.2. So let's go ahead and plug them in here. So we have negative 2.2. So this will give us about negative on top and then negative on the bottom. So the ratio is positive. And when we plug in 0, that's the last interval we're testing. We get 0 here and 0 here. So we see that the top is negative, the bottom is positive, so the ratio is negative. All right, so once we finish testing, now we decide which interval we want for our solution. We want the expression to be greater than 0. So that means we want positive interval. That's only this one right here. So that means our solution for this interval is going to be negative 5 over 2 to negative 2, because that's the only interval where the expression is greater than 0 or positive. All right, so let's go into number 19. 19, we're going to do a lot of factoring and then simplify. So every time you see division, change it to multiplication, but remember to reciprocate the next fraction. So I'll rewrite first. X squared minus x minus 30 over x squared plus 5x times, I reciprocate the fraction. So that's x cubed plus x squared over x squared minus 5x minus 6. And now we can factor everything and then cancel. So x squared minus x minus 30, that's going to factor into x minus 6, x plus 5. And then on the bottom, I can just pull out an x, and then I get x plus 5 times. Now the second fraction, I can pull out an x squared, then I have only x plus 1. And on the bottom, I can factor that into x minus 6 and x plus 1. So making sure everything looks good. Yeah, now we can cancel. So I can cancel x minus 6 with x minus 6. X plus 5 with x plus 5, x plus 1 with x plus 1. One of the factor of x will cancel with that. So I'm left with only one factor of x on top. So everything reduces to just x over 1 or simply x. So that will be our final answer for 19. Now for 20, we're going to find all solutions to this equation. So let's go ahead and isolate the radical expression by subtracting 1 from both sides. You have square root of 9 minus x is equal to x minus 7. And now we can square both sides. So on the left side, we can get rid of the radical. So that's 9 minus x. On the right side, we expand. So we have x squared minus 14x plus 49. Since it's a quadratic, let's move everything to the right-hand side. So we can add x to both sides and minus 9. So you have x squared minus adding x, so that will be 13x, and then minus 9, so plus 40. And now we try to factor this. So this can be factored into the following. We're going to need 5 and 8 because they sum up to 13. So negative 5 and negative 8. So our x values are 5 and 8. Now we need to check our answer because it's a radical equation, so check is an important step. So for x equal 5, well, it makes sense. Well, square root of 9 minus 5 plus 1 is equal to, is that equal to 5 minus 6? So 9 minus 5, that's 4. You square root that, you get 2 plus 1, that's 3. So is 3 is equal to negative 1? That's not true. So 5 doesn't make sense. Now what about 8? Square root of 9 minus 8 plus 1, is that equal to 8 minus 6? So 9 minus 8, that's 1. Square root of 1 is 1. 1 plus 1, that's 2. Is 2 equal to 8 minus 6? 2. Check. Yes. So the only solution for this equation we have is x equals 8. So you do have to be careful and check your answer if you have equation that involves square roots. So for number 21, we're going to sketch this exponential function using transformations. So I'm going to rewrite this function so that my base is a whole number instead of a fraction. So we can rewrite the function as y equals, so instead of writing 1/5, I'm going to write 5 to the negative 1 power, and then that's raised to x plus 1 and plus 2 out there. And then by using laws of exponents, this can also be written as 5 to the negative x plus 1. So I just multiply these right here, just keeping parentheses around x plus 1. And then plus 2 outside, like that. So this means that we're going to start with the function, the exponential function 5 to the x, and then we'll apply transformation. So first we're going to reflect. So the negative in front of x represents reflection over the y-axis. And then that plus 1 inside the parentheses, that's going to represent a shift to the left 1 unit. So this is a horizontal shift, left 1 unit. And the last thing is plus 2 right here. That's going to represent vertical shift. So we're going to go up 2 units. And that will give us the final sketch. So here's our XY plane. And let's suppose that 5 to the x, we know that it looks like this. That's 5 to the x. And this point right here is 0, 1. And it has a horizontal asymptote at y equals 0. This is 5 to the x. Now, if you reflect about the y-axis, you're going to get a graph that looks just like this. And then if you shift 1 unit to the left, so the 0.01 will transfer right here, negative 1, 0. So it's going to look something like that. And then we're going to go up 2 units. So negative 1, 1, going to shift up 2 units, 1, 2. So it's going to be sitting at negative 1, 2, somewhere right here. And we make this shape. But before that, we also need to realize that the horizontal asymptote will also shift upward if you're shifting the graph up by some units. So let's label the horizontal asymptote first. So shifting 0 plus 2, 2 units up. So here's your new horizontal asymptote. Something like that. Y equals 2. And I just make the shape of the graph. So here's my point, and my graph will look something like this. And this is the point, negative 1, 3. So that is your final sketch for this function. So let's go ahead and write down the domain. The domain of this function is all real numbers, as we know from exponential, or you can just simply look at the graph. The range of this function, it's going to be from the asymptote, so 2 open, all the way to infinity. And we see there is a horizontal asymptote. So we can say that the horizontal asymptote, HA, is going to be y equals 2. So these are also additional information we can write down for this graph. So for y-intercept, we're going to set x equal to 0. So to find this intercept, we're going to set x equals 0. So you'll have y equals 2 plus 1/5 to the power 0 plus 1, that's 1. And that will give you 2 plus 1/5, and that is about 11/5. So this y-intercept is actually 11/5. That will be the y-intercept. For number 22, we're going to sketch this logarithmic function. So we're going to write down the transformations and then start sketching. So we have log base 8 of x minus 6. So we're going to start with our basic shape. So start with log base 8 of x. And then we're going to shift. First, it's going to be this one right here. That's a reflection over the x-axis. So we're going to reflect over the x-axis. And then the final shift
would be this piece right here, x minus 6, which means we're traveling 6 units to the right. So then we're going to shift right 6 units. And that will give us the final sketch. So let's go ahead and start sketching our XY plane. A logarithm of any base, we know it looks like this. So that's the logarithm. Let's call it base 8 of x. And it has x equals 0 as the vertical asymptote. And this point right here is 1, 0. Now let's reflect about the x-axis. When you reflect this about the x-axis, your graph would look something like this. That's the reflection. And then when you shift the right 6 units, you're also shifting the asymptote. So the asymptote, you add 6 units to the right. I'm going to go ahead and erase this, but just hold on to that thought. So 6 units to the right. So 1, 2, 3, 4, 5, 6. So here is the new vertical asymptote. And then we know that this point right here gets shifted 6 units to the right. So it's going to be right here, 7, 0. And we just preserve the shape. So I'm going to extend my x's a little bit so that it's easier to observe. And we preserve the shape. So it was reflected. So it's going to look like this. So reflected over the x-axis and then shift right 6 units. So that is our graph. So this is our final sketch. That is our function f of x equals negative log base 8 of x minus 6. Sorry to squeeze that in. Let me just write it right here. So this is f of x equals negative log base 8 of x minus 6. So focusing on that graph, let's go ahead and write down domain range. So the domain of this function is going to be from the asymptote to open 6 to infinity. The range is all real numbers because everything makes sense. And we have a vertical asymptote at x equals 6. And the intercept is also labeled. That was actually the point of transformation, 7, 0. And there's no y-intercept. So that completes our graph for this function. So for number 23, we're working with an application of the exponential and logarithmic functions. So the initial size of a bacteria culture is 1,000. So that's the initial size. You can label that as P initial. So the initial amount is 1,000. After 1 hour, so when T is 1, the count is 8,000. So that gives us extra information. The time, so I can use this notation. The amount after 1 hour is 8,000. We want to know after how many hours will the bacteria population reach 15,000. So we want to know the time when it will reach this amount. So first, let's find the model. So based on this information, we know that 8,000 is equal to 1,000 times e to the rt. Well, t is 1. So we're using the model, the amount after any time t is the initial amount times e to the rt. Divide both sides by 1,000, you have 8 is equal to e to the r. And now apply ln on both sides. So you have ln of 8 is equal to r. So that's the rate, which means our model, the amount at any time t, is 1,000 times e to the r, that's ln of 8 times t. And we simplify this. So here you're going to cancel out e and ln, which means 8 will drop down as a base. So our amount is going to be 100 times 8 to the power t. So that's the formula we're going to use to answer the question. So we want to know what is the time when it will reach 15,000. So let me go ahead and just move this right here. So we have more room. So we want to know what is the time when the amount at that time is 15,000. So let's go ahead and set it up right here. So 15,000 is equal to 1,000 times 8 to the power t. We're looking for time. Divide both sides by 1,000. You have 15 is equal to 8 to the power t. Now to bring down the power t, which we're solving for, we're going to apply ln on both sides. So ln of 15 is equal to t times ln of 8. And divide both sides by ln of 8. So the time is ln of 15 over ln of 8. And that's the simplified answer. There's nothing else we can do here, so we'll leave it at this. For number 24, we're solving an absolute value equation. If you're not so comfortable with decimal, write it as a fraction. So I can write 0.1 as 1 over 10. So we have 3x plus 5 in absolute value is equal to 1 over 10. And you separate this into two separate equations. So we have 3x plus 5 is equal to 1 over 10. Or we have 3x plus 5 is equal to negative 1 over 10 by definition of an absolute value. And then we solve both of these equations. So subtract 5 from both sides, you'll have 3x is equal to, so here you need to use common denominators. So 1 over 10 minus 5, multiply this 10 over 10, so that's 50. And then 1 minus negative 50, that's negative 49 over 10, and divide both sides by 3. So you'll get x is equal to negative 49 over 30. So that's one possible solution. And same thing on the left side, we subtract 5 from both sides. You'll get 3x is equal to, again, now here we're going to subtract. So negative 10 minus 5, put them in common denominators. You'll get negative 51 over 10. Divide both sides by 3. So you get x equals negative 51 over 30. That's another possible solution. Now let's check your answer. So plug this into the original and see if it makes sense. So when I plug in negative 49 plus negative 49 over 30 into this expression, I get 3 times negative 49 over 30 plus 5. So let's see if that is equal to 1 over 10. So 3 and 30, that simplifies. So you'll get negative 49 over 10 plus 5. And then you simplify this. So 49, negative 49 over 10 plus 5 times 5 by 10 over 10. So you'll have negative 49 plus 5, that's 1 over 10 in absolute value. So this checks. So this seems to work. Now let's go ahead and check the next one. We're plugging in negative 51 over 30. So again, this will simplify negative 51 over 10 plus 5 in absolute value. Write 5 as 10 over 10. So you have 5 times 10, 50 over negative 51 over 10. So that's negative 1 over 10 in absolute value, which is negative 1 over 10. So both of these make sense. So that means we can conclude that our answers are both of these. So here's our last problem for this test. We're going to sketch this trigonometric function. So we're going to write this formula in standard form. So standard form of any trigonometric equation is usually in this form. So y equals a times sine of some k times x plus or minus, let's say minus b plus some c. So I need to factor this right here. So factor out a 2. So you'll have y equals negative 5 sine of 2 times x plus pi over 2. So the reason I have to write pi over 2 here, because when I redistribute, it's pi. So the 2 and 2 cancels out. So be careful to make sure to do that when k is not factored out from the inside. So now we can identify what each components are. So absolute value of this is a, this is your k, and that's your horizontal shift. So we know that the amplitude of this graph, it's going to be the absolute value of negative 5, which is 5. So the maximum will be 5, minimum will be negative 5. The period for this graph is P equals 2 pi over K. K is 2, so this is 2 pi over 2. That's pi. And we have a phase shift or horizontal shift. We're going to the left, pi over 2 units. So we're going to subtract every point on the x-axis to go to the left, pi over 2 units. All right, so now let's take a look at the graph. So one period is going to be completed from 0 to pi, and then we'll shift pi over 2 units to the left. So here's how one of the sketch will look like, not the final sketch. So this is just reflected in period of pi. Let's suppose this is 5 and this is -5. So we're going to complete one cycle at pi. So subdivide this into 4 equal length. So this is pi over 4. This is 2 pi over 4. That's pi over 2. And then 3 pi over 4. And then 4 pi over 4. That's pi. So sine usually goes like this. So this is how the sine curve looks like. No, that's not the one we're going to draw. We're going to do the reflection of it because of the -5 in front of our equation. So we're going to start at 0, 0, and then right here, and then at 0, and then 3 pi over 4 at 5. So this is the -5 sine 2x. So this green is -5 sine 2x. And now we need to shift every x coordinates to the left by pi over 2 units. So let's go ahead and do that. So this point gets shifted. So our new point, so the new x coordinates are the following. So 0 goes to pi over 2 units to the left. So 0 minus pi over 2, that's -pi over 2. And then pi over 4 goes to pi over 2 units to the left. So now we need to put common denominators. So this would be negative pi over 4. And then pi over 2 minus pi over 2, that's going to go to 0. And then 3 pi over 4 minus pi over 2, that's going to be just pi over 4. And the last point, pi, it's going to go pi over 2 units to the left. So that will be pi over 2. So these are the new points. So let me just circle them for you. So these are the points once we shift them pi over 2 units to the left. So let's go ahead and label them. This is -pi over 2, -pi over 4. 0 is there, pi over 4 is there, pi over 2, everything else is there. So here's our final sketch. This is there, this is here, 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 and here. So you just replicate the points, but they're at new location. Here's one period, and then of course it continues on. So this is the shifted one. This is the final sketch. That's y equals -5 sine of 2 times x plus pi over 2. So I always like to do 2 graphs when it comes to horizontal shift and a reflection. So you get the one without the reflection first, and then reflect, and then shift. So 2 pieces makes more sense. All right, so this is it. I hope you enjoyed the video. Hopefully it was helpful in your studies. See you next time.